Anjali Samani, Director of Data Science and Data Intelligence at SalesForce, and an old friend. Welcome to the Data Exchange Podcast.
Thank you. Excited to be here. Thank you for having me, Ben.
And for our listeners, Anjali actually has a great background because she's done data science and machine learning in a variety of settings and domains. So, for example, she started out in finance and then has worked in consulting roles, but which we will get into. But first off, so we first met many years ago when you were part of ASI Data Science, now called Faculty.ai, which was one of the first, I guess, outfits that took PhDs in hard sciences and engineering and put them through a boot camp and then converted them into industrial data scientists. So actually, before I don't know what you mean by, oops, I guess outfits to before we talk further about what you're doing now. So, quick question. So, would you hire a PhD from one of these boot camps today?
I would certainly hire folks from faculty because I know how their process works, and I've worked with a lot of them. I think hiring other data scientists from boot camps here, it's really a mixed bag.
But qualification is that they already have a PhD and then they go through a boot camp. So even there, it's a mixed bag.
Yeah, that's certainly been my experience. With a lot of the folks with PhDs, the one thing that's great is, analytically, they tend to be very strong. They know how the research process works. The rigor is very much there. I think the downside is they suffer from what one of my former colleagues used to say, PhD-itis, which is kind of the analysis paralysis part of it. And they sometimes lack the business focus or the customer focus. And I think that's the one that I would want to really check for when hiring PhDs from boot camps.
So I know that in the early days of those boot camps, so one of the things that you folks really learned early on is the importance of real world data and real world projects, right? Because as many of our listeners know, you can actually go online and copy and paste Python code on kind of open data sets, but they're not necessarily representative of the kind of work you need to do in industry, right?
Yeah, and that continues to be a challenge. I think even today, many companies are very reluctant to share proprietary data. There's a lot of sensitivity around it. So I think what faculty have been able to do has been really great because they've been able to get organizations to part with that data. I think most other boot camps, they don't really have that luxury. So fellows from these programs often have to rely on publicly available data. The great thing about that is, they learn to build those ETL pipelines. They learn what it takes to source and process a lot of this data because it can be pretty noisy. Hopefully, they learn to think about why the data was collected and what issues and biases it may have that can influence the outcome of their models. They don't often have the hard real world experience. And I think one of the things, and maybe things have changed at faculty, I don't know, but one of the challenges also is, understanding how to deploy models into production. I think that's a skill set that is sorely missing for a lot of new data scientists, people who are either transitioning from academia or from other careers, and also for data scientists who've been through a data science degree as well. I think these days, with the tools and technology that's available, being able to build and train a model is almost table stakes. Yeah. It's very easy. Gone are the days when you had to code things up from scratch. I think now the thing that really separates the great data scientists from the not so great ones are all the peripheral things. So how good are they at translating that business problem into a data science problem? How good are they at building those features and coming up with creative solutions?
How relentless are they in terms of finding data?
Yeah. And also, what happens once you've built this model that, works wonderfully in that laboratory environment? How do you deploy it? How do you monitor it? How do you keep on top of data drifts and concept drifts and all of those things? And, how do you seamlessly take models in and out of production? So the whole CI/CD kind of equivalent for machine learning. The software engineering world has been doing this for a long time. They have come up with some really great ways of ensuring that they're able to continuously integrate and deliver new features. I think in the machine learning context, that is still not very well solved problem.
Still evolving. I mean, honestly, I think even I think where the ML community is getting better, even in the QA validation, testing models before they deploy, and then the whole infrastructure for monitoring and retraining or root cause analysis if there's something wrong. That really depends on where you work at this point.
Yeah, there aren't tools that do all of the things that you might need. So it's either a case of patching together a lot of open source tools or investing in a platform, but then still, plugging in some of the open source tools. So that's, the whole ML ops piece continues to be a big challenge. And it's one of those things also that, it's hard to get hands-on experience unless you've done an internship or something where you're forced to do something like that.
So if a listener has a PhD and wants to transition to become a data scientist, would you recommend one of these boot camps?
I certainly would, because I think it definitely exposes them to all kinds of problems and it will still give them a lot of the foundational pieces. But I don't think that in and by itself is enough anymore, in part because the competition is so fierce, right? Now, a lot of boot camps, a lot of universities are churning out data scientists at a phenomenal rate. So there are just a lot more people about. And certainly for a lot of larger organizations, like SalesForce, and even actually for a lot of the startups, gone are the days when people want to invest in separate data engineers, machine learning engineers, data scientists, especially if they can find the not so rare unicorns with both data science and some of the MLE skills. So the organizations are sort of increasingly raising the bar in terms of what they're looking for. So that's why I think that just doing a boot camp in and by itself is no longer sufficient.
So the one good thing about boot camps, particularly I think faculty does a good job of this, is helping you overcome the cold start problem for your personal network, So suddenly you meet maybe alumni of the faculty boot camp, or you meet your peers in your class, or even guest speakers or people from other companies, and then they have kind of their demo day kind of thing when you build another network there. Because I think for maybe the people that you probably taught, because you guys were teaching people from top schools like Cambridge and Oxford, right? So they definitely were smart, but they had no network to begin with.
Yeah, no, they were some of the smartest folks I've worked with in my career, but the network piece is definitely very important, not just in terms of looking for a job, but also, when you come across a challenging problem, it always helps to be able to bounce ideas off of folks. Data science is so broad that you're never going to be able to be an expert in everything. And a lot of the value I've seen comes from borrowing concepts from different disciplines and merging them together. There's a lot of synergy that comes from that. So I think that piece, something like a boot camp, will give you in a way that not many other places will. People have experiences and expertise in a lot of different domains, either from their academic work or from any previous work experience they have. So I think some of that synergy, it helps a lot. It goes a long way in helping you to gain experience in a different way.
So if you were to design some of the courses, because I know in the early days of faculty, you basically ran those boot camps, right? So you designed those courses. Would you design them the same way today?
I would design them a little bit differently today, for sure. I think so I would split the difference kind of in two ways. One is the technical side, and then one is the mental side, the mindset, if you will. And I think on the technical side, definitely experience with a lot of the engineering principles and skills, both in terms of the software engineering part, writing very good quality code, and then there is the machine learning engineering piece. How to deploy models into production. What are the kinds of things you want to look out for? If you were deploying something into production, how do you monitor things, and how do you make sure that things are refreshed on a regular cadence? Lot of the.
By the way, Anjali, one good thing about finance, because I spent a few years in a hedge fund, is there, if you start losing money,
Yeah.
so it's a bit of a different domain in the sense that monitoring and caring about what happens in the real world really hits you hard.
Yeah. I think, when there is a very short feedback loop, it becomes very easy. You very quickly learn that you have to stay
Or
on top of these things.
plus, usually in a trading environment, everyone sees what's happening.
Right.
So, who built this model?
Yeah, no, and I mean, even within finance. So I recently spent a few years at a fintech startup called Circle Up, who were doing private equity investing in CPG, early stage CPG startups. And that's an area of finance where the feedback loops are extremely long, right? You can build a model that might recommend a few investments, but you don't find out for another 5-10 years if you're lucky.
You've changed jobs before they find out who was responsible.
Exactly. So having that rigor on what to do once you put something into production, to my mind, is very important, and that's something I would start to include in some of these courses.
Speaking of which, when you were doing these courses, this whole notion of responsible AI, which is really an umbrella term for risks involving models, right? So this would be fairness, explainability, security, privacy, safety, reliability. Was there, but it wasn't top of mind for many teams, right? So
no, definitely not.
So that might be something you would add into the coursework now, right? So
absolutely, yeah. So for healthcare companies and financial services organizations, for them, that was very much top of mind, because they are under a lot more scrutiny. As industries, they're a lot more regulated. So they were certainly thinking about it and have been thinking about it for a long time. But I think the rest of the world, it wasn't as much top of the mind. I think there is a very strong bias towards just cutting down that time to insight or time to value. And I often feel like, that's the wrong way to incentivize data scientists. It's almost reminiscent of, the financial services industry pre-credit crisis, where if the incentives aren't set up correctly, then you are almost incentivized to take shortcuts in a way that is not responsible, in a way that is not, that doesn't serve the organization long term.
So you've also had a chance to do data science and machine learning in many different settings, including consulting, and now you lead a team at Salesforce, which is basically, I guess, doing internal consulting in some ways, right? So
Mhm.
so for people who are kind of casting around for what to do next, because we're also recording this in January, where traditionally people kind of reassess their current job situation in January, right? So,
Mhm.
what are the pros and cons between, let's say, working for a vendor, a tool vendor, inside a consulting kind of, or in a consulting kind of role, or something more like what you're doing, which is doing data science, deep data science within one specific company, right?
So I really loved my time consulting because that was when I was transitioning from financial services into data science. And I wasn't really sure where I wanted to be. So consulting gave me exposure to a lot of different kinds of problems, a lot of different organizations, both public and private sector, startups and larger corporations. And that was, for me, very instructive. It was really great experience, just understanding the different flavors of problems that are out there. I think if you work for a tool vendor, then you would get some of that exposure, and you would likely build a lot of engineering type skills if you're actively contributing to the development of the
Or
platform.
you're like in a role where you have to help a customer, right? And there
Exactly.
might be some kind of customization involved, right? So
Right. But if you're looking to really get deep into a problem or an industry, if you are looking to build a lot of models, or, if you're looking to solve business problems using data and data science, then that is something you may not get working for a tool vendor. You're never going to be able to see something from start to finish, something that goes from a concept to a fully deployed product, and how it impacts the bottom line. So it just really depends on where you are in your career and what are the kinds of things you want out of it.
so in terms of Anjali, in terms of data types and data sources, I noticed that your PhD is computer vision,
Mhm.
but it may have preceded deep learning.
Oh yeah, definitely.
Yeah. So
Back
then,
then,
and
they
now,
train
of
and
course,
roll.
the
Yeah.
computer vision, it's all deep learning, and it's also, there's a lot more tools for it, right? So a lot more possibilities there, including
Mhm.
with video, right? So, and over the last couple of years, it's about large language models and text, right? So, um, so right now in your work at Salesforce, are there specific kinds of problems that you folks are working on that involve any of these kind of bleeding edge techniques?
Not so much on my specific team. So I work on a team that is focused exclusively on Salesforce's internal customers. So our customers, our stakeholders tend to be the exec leadership team. They tend to be the general managers of our different product lines, and we help them. We provide them with intelligence and model outcomes that will help them to make data informed decisions about product strategy, or about financial decisions, or one of the
So is these
one.
are these ongoing, or are they kind of more one-off? Like, I'm an executive, can you folks build me a forecast, or can you optimize these different parameters for me? So how does it work?
It tends to be a combination of both. The established products that the broader team that I'm part of has built, they tend to be something that's refreshed on a weekly, monthly, quarterly cadence, and provide ongoing actionable insights to the leadership team. So the specific team that I lead, the Einstein Guidance Team, our flagship product is a forecasting tool that does sales forecasting, but at multiple levels. So SalesForce is a large organization with a lot of sales leaders that operates in a lot of different geographies, and there are a lot of different products. So doing sales forecasting for something like that is a pretty woolly task. You have a lot of different hierarchies, and then through that, a lot of other kind of tangential things come out, whether it's in terms of which customers sales team should target, or which specific deals, or what do the cross-sell upsell opportunities look like, who is likely to churn, and how we can manage some of those things. So these are the kinds of use cases my specific team works with.
So actually, I joke occasionally with friends, but one of the kind of big problems in ML is what I call one-off ML, because basically we talk a lot about ML ops and putting things in production, but inside companies there's a lot of ML decisions that are driven by ML, maybe one-off.
Yeah, it's a black hole.
If you want to review them like 6 or 7 months later, who knows if someone actually documented it well enough so you can recreate and reproduce it.
Oh my God, that's my pet peeve. Like I hear a lot of this, oh yes, we had a model or we did some analysis. And when I say, oh, can I see it? Because I don't want to go and reinvent the wheel. I just want to, build on top of what's already been done. And nobody knows where that work is. The people who built it or who did the analysis have kind of long been gone. So that's the process. So this is the other piece I was talking about in terms of how I would change some of these courses now with the hindsight. And the mindset shift is another one that I would focus very strongly on. So bringing a lot of rigor around process. How do you kick off projects? How do you wrap them up so that that work isn't wasted, or you're not permanently tied to maintaining poorly designed or built products or models? It's bringing that production first mindset and thinking about tech debt, and just really striking that balance between, providing that or cutting down that time to insight or value, but also not shooting yourself in the foot in the process, because these things always come to bite you, a few months or years down the line.
So Anjali, so in your mind, what makes business time series forecasting challenging? Is it basically getting all of the data that you need? Is it because nowadays, as you alluded to earlier, there are many probably packages that you can use where basically it will come down to some kind of hyperparameter tuning kind of thing, right? So what makes in the real world, what makes forecasting hard?
Data. It's always the data. Yeah, it's whether it's
aligning the different things, right?
Yeah, it's I think it's data in all its forms, right? So acquiring data, in large organizations, data sits in so many different places,
systems.
And it's all of these systems don't always talk to each other particularly well, or on at one level you think you have a ton of data which will help you to forecast all these different things, but things like entity resolution can become challenging, where you can have two different data sets which are conceptually very linked, but when you want to kind of connect them together at that entity level, it's really hard.
Oh my
because they're collected by different teams, processed
company name, for example, right?
Names, addresses, even simple things like just people changing the the case or spacing or abbreviations, all of these things can totally throw things off. So data is always the biggest challenge. For organizations that are as old as, say, for example, Salesforce is, data has gone through so much. So in theory, you have a lot of historical data, but the business has changed. How data was collected and processed has changed. Maybe even what things are called has changed. So sometimes it's really hard to keep up with some of these changes as well. And so it's just the data, acquiring it, processing it, really understanding the provenance and the processing that's gone on. That's what makes it hardest.
Right. By the way, for our listeners, we talk a lot about, AI, deep learning, all sorts of things, but really for many businesses, this forecasting thing is at the heart of what they do, right? So forecasting and optimization, right?
Exactly. I think that's the other challenge with a lot of these, boot camps, and even data scientists who are transitioning into this space. A lot of them come with the expectation of building the most technically advanced deep learning models to solve problems. And the reality is that for most businesses, there just aren't enough use cases that require that level of sophistication in terms of models. A lot of them don't even have the data to be able to do it.
Or there's very few jobs where your job is building models.
Right. And I think, that's something not many people appreciate. Even now, I will interview candidates. And when I ask them, do you have a good sense of what you're expecting to do in this role? And it's, the expectations that people have versus what the job is going to be is often so misaligned.
And in some specific areas, it's just also the lack of examples. For example, I'm interested in reinforcement learning, and I'm an advisor to Anyscale, which is the company behind Ray, and they have a popular reinforcement learning library, RLib. But I keep urging them, you need to have examples in there that people can relate to, like either time series forecasting or recommenders, right? Because in an area like that, the default example is like from robotics,
Yeah.
And it's not something you can, even if you master that example, it's not something that you can map to your day-to-day work, right? So,
right, exactly.
Yeah. So you've transitioned to more of a leadership and management role. So first of all, is this something you recommend, or is this the natural progression of a data scientist? Because so there are engineers that choose to not go into management. And I don't know if there's such a thing in data science yet, like the distinguished engineer or something like that, where you're kind of a mentor, individual contributor and a mentor, but you're not necessarily responsible for someone's performance reviews, So.
I think the data science equivalent is the principal data scientist.
Oh, yeah, that's right.
Some flavor of that.
Yeah.
So I mean, now more and more organizations are coming up with these multiple development tracks for people who either want to go into that leadership management kind of a role versus technical leadership role. So those both of those options are definitely open to people.
And is this something you recommend? Transitioning to the more of the leadership role?
I think I recommend it just because people then get to appreciate, that leadership or management isn't just the soft stuff. I think I've certainly been stretched in ways that I wasn't expecting to, or, in ways that I wasn't prepared. I think technical leadership, rightly or wrongly, I think, if you can always read up on something, you can always spend hours learning something, and you can keep building models and writing that code and perfecting your craft. With management and leadership, it's all about people, and that is challenging in a very different way. Just when you think you've figured something out, you'll have somebody new join your team who is who is a very different kind of individual, and everything you've learned doesn't always work, or what's worked historically with folks doesn't work with them. So I would definitely recommend it. I understand it's not everyone's cup of tea.
So if you were to and I'm not saying you're going to do this. So people from Salesforce, she's not leaving Salesforce, but let's say you decide to go to another company like Circle Up, where you're going to build a data team from the ground up.
Mm-hmm.
So based on your experience at Circle Up and at Salesforce, is there anything different about how you would proceed in terms of assembling and putting together this team?
So I actually had the privilege of building a data science team ground up at Circle Up. The team that I was leading, I had the privilege of recruiting and hiring all of them. And I think, would I do things differently? I think I would probably interview differently, skills and things that I look for. So back then, like I said, the focus was very much on data science and the analytical skills. Right. And that was also right for the age and stage of the company at the time, and what we were looking for. But I think 3-4 years on, a lot of those things have become table stakes. So I would still look for that. But if I had the choice between all else being equal, I would pick somebody who also has the engineering chops to be able to.
I've always felt this way from the beginning.
You were way ahead of the game.
that data engineering and software engineering skills are harder to teach, and also in many ways, I guess, especially now, it's much more pronounced because the tools for building models have become much more accessible, right?
Yeah, I think right now, the good thing about sort of having these tools is it also lays bare people's analytical skills. So, you can often, I'll be in an interview setting where somebody's working through a notebook and they'll say, oh, yes, I would go and, build this model using this function in scikit-learn. And we're like, okay, well, do you know what's happening under the hood? And when you sort of start asking some of those questions, like, okay, why would you pick this versus that? Or, why would you set your parameters this way rather than in some other way? That's when you really sort of get to the heart of whether somebody really understands what even something as simple as linear regression is doing, or what, the function in Python, in the different libraries, they're all slightly different. So why you would use one over the other. So I think, those kinds of things now become very important. Or you give them a simple EDA problem, and it really helps you to understand whether they can really think analytically and systematically through a problem, or, evaluate a data set in a systematic way.
So what in your current role, so are you folks, do you folks talk about responsible AI sort of topics?
We certainly do, yeah. It comes up in a lot of different contexts. For a lot of the forecasting work, it's about making sure that we're backtesting thoroughly. We are being very clear about performance and assumptions, and being very specific about where you can and can't trust the forecasts, whether that comes in the form of a narrative or in the form of some kind of confidence intervals. Explainability is also a big part of what we do. So increasingly, the focus is shifting from having a super accurate point estimate to something that makes a lot of sense, even though it's not super accurate. If it's directionally correct and people understand why the number is what it is. Of course, you don't want to be off by orders of magnitude.
Do you give them a confidence interval?
We, in some cases, yes, we do. Yeah.
So Anjali, what do you think? So in closing, what do you think about as we were talking here? The word optimization keeps popping in my head because in many businesses, actually, you need to optimize, I don't know, your supply chain or this or that. So is that something that you folks also do?
We do flavors of it, and
Yeah.
Salesforce is a big organization, so there are definitely teams who are more focused on it than we are. We definitely have use cases, but they've not really matured into established products in the way some of these forecasting tools are.
Yeah, it seems like this is one area that data scientists, I guess a couple of areas that I think data scientists know about, but don't necessarily go deep in is this optimization and also to some extent stats, right?
Yeah,
Because basically just setting up the right experiment and things like that, because everything now is machine learning. People have forgotten about basic stats in some ways, right? So
yeah, and that's another good one for aspiring data scientists to focus on, unless you've come again from finance or healthcare, where setting up these experiments and looking at things from a statistical rigor perspective is the norm. Not many people are as aware of it.
yeah, and a few months ago, I talked with Jay Sharma. He's building kind of a modern experimentation platform, and it's really striking how many startups there are around ML and ML ops. But it seems like this next level of application, the application layer in the stack seems like rife for disruption, right? So if you can make optimization much more accessible to regular companies, because we all read about all these cool experimentation platforms at Netflix and Google and these leading tech companies, and even Booking.com has a famous experimentation platform. But it seems like now with the rise of these modern data platforms, it might be possible to make this capability more widely available.
Yeah, and I think if they can do that, it opens up a lot more use cases and opportunities for businesses.
And
I
data
think
scientists. Yeah.
yeah, optimization and then sort of a lot of the probabilistic modeling, that's another one that I think would merit folks sort of looking at and building capabilities within either existing platforms or new platforms.
And with that, thank you, Anjali.
Thank you, Ben. It was a pleasure speaking with you as always.